part D, we have x to the third times x to the negative seventh. Now, you're going to notice on the board, I have that same problem written 2 different times. And I have a big line here with the word or between those. What I'm going to do is do this problem in 2 different ways. And it really comes down to whether you look at this x to the negative seventh and say, that's the first thing that I want to deal with, or if you look at that x to the negative seventh and say, I might eventually deal with him, but I'm not going to worry about him as the very first item. So what's happening here is that whenever you have a problem that involves multiple rules of exponents, there are multiple ways of getting to the same answer. So I want to make sure that you see that there are multiple ways to get to exactly the same answer, and both of them will ultimately give us the same thing. So let's go ahead and see what happens then if we look at this problem and start off by saying, I'm going to go ahead and say that x to the negative seventh, I'm not going to worry about the fact that he's a negative exponent right now. I'm going to postpone that until a little bit later. I'm going to say that this is x to a power times x to a power. If I have x to a power times x to a power, we have the product rule. And the product rule says if you have x to a power times x to a power, you can add those exponents. So we have x, the same base, to the 3 plus negative 7 power. Well, if I add a negative 7 to 3, I'm going to get a negative 4. And now that I have x to the negative 4 power, I can use the negative exponent rule. And the negative exponent rule tells me x to a negative power is going to be 1 divided by x to that positive power. So the answer here is 1 divided by x to the 4th. However, once again, maybe you looked at this problem and said, the very first thing I want to do is come in and say x to the negative 7th, that's a negative exponent, I'm going to use the negative exponent rule to rewrite it. And you can. So let's check it out. We're going to have x to the third times x to the negative 7th, using the negative exponent rule, is going to be 1 divided by x to the 7th. Because again, anytime you have x to a negative power, that x is going to get moved into the denominator. Something in the numerator moves into the denominator by using that negative power. Well, now that I have this then, this is a fractional multiplication problem. To make both fractions look more like fractions, I'm going to take the first fraction and say he's over 1. And now this is going to be x to the third divided by x to the 7th. Well, now that I see we have x to a power divided by x to a power, this is an example of the quotient rule. And the quotient rule is going to tell me that if I have x to a power divided by x to a power, I can subtract those exponents. So this is going to be x to the 3 minus 7. 3 minus 7 is a negative 4. So this is the same as x to the negative 4. And now that I have that, I can use my negative exponent rule. And x to a negative power in the numerator becomes x to the positive version of that power in the denominator. And if you compare the answer that I have here on the right-hand column, it's exactly the same answer as I have here on the left-hand column. So when I look at these 2 different techniques, I'm drawn to this first technique because it's a little bit shorter. But if you like this second technique, it's completely equivalent, and it gives us the same answer at the end. So feel free to use that if that's the technique that makes the most sense to you.